Okay, all right. And I think I'm ready here now. Okay, make sure everything's going. Okay, all right, I'm good. Okay, so to begin with, we're looking at polynomial functions. We looked at this at the end of class on Thursday, kind of the second half right there. So the first thing is the degree. The degree, we kind of learned that the degree is the highest power. So what you have to do on this is you have to look at these exponents. There's actually 3 exponents on this problem. Okay, this is in a factor form. Thank you, Hugo. Okay, so if we do this, when you do the degree, you need to add these up. So you need to do the 1 plus the 2 plus the 3, and then that will give you a degree of 6. Okay, and that degree will tell you what the graph looks like. Okay, and we talked about that. If it's an even degree, the graph either goes up or it goes down. The leading coefficient will tell us which it is. Okay, so now when you do this leading coefficient, we talked about this last class. Watch this real carefully. Okay, so this will go like this. We've got -1 is an important number. Everything that's in front of x is very important when you do a leading coefficient. So what I'm going to do is I'm going to take these things I'm highlighting, just the coefficients of 1. You do have to pay attention to those exponents too, because if you don't, then it'll probably mess you up, okay, more than likely. So we're going to take -1. We're going to multiply that by 1 to the second, and then we're going to multiply that by 1 to the third. Okay, thank you, Crystal. Okay, and then just work that out. So that would be -1 times 1 times 1. So that's -1. So the idea would be like if you multiplied this polynomial out, and you would never want to do such a thing, then you would end up with the highest power would be 6, and the number in front of that highest power would be -1. So if you multiplied this out, you would have -1x to the 6th, then you would have a whole bunch of other terms. That's what happens. So there's no way you want to multiply it out. You want to just reason out the degree and leading coefficient that way. Okay, is everybody okay with what I'm doing there? Okay, all right. Now, the nice thing about the zeros is, we talked about this last time, is the zeros come from these pieces right here. Okay, each of these factors, what you need to do, and you can learn to do this in your head. It's not too hard to do it in your head. You're just going to do this. You'll do -1 x equals 0. You'll solve that equation, which you can do in your head. You'll take x plus 5 equals 0. You'll solve that equation. Then you'll have x minus 6 equals 0. You'll solve that. So that gives you what we call a zero. These are numbers that make the polynomial become 0. Okay? So what's the answer to the equation -1x equals 0? Isn't that just 0? Yeah, okay. So one of your zeros is 0. The multiplicity is the exponent. Okay, so that is 1 like that. Okay, what we learned last time is if the multiplicity is odd, 1 is an odd number, that means you cross through the x-axis. Okay, and then when we put together our graph, I'll kind of tell you how that works then. Okay, go to the next equation. What is the answer just in your head to x plus 5 equals 0? -5, thank you, good. So you don't have to show any work when you're getting the zeros because you're just going to subtract 5 anyway. So you get -5. The multiplicity of that is 2. That's the outer exponent, so that's a 2 like that. Okay? Anytime your multiplicity is even, that means you're going to touch the x-axis. You don't go through the x-axis, you touch it. Okay? All right? Then the last thing we're going to look at is x minus 6 equals 0. In your head, what's the answer? What minus 6 is 0? That's me. I don't know what was causing that. Okay, that's weird. Okay, so what's the answer in your head? 6, thank you, good. Okay, or you could add 6 to both sides. So you get x equals 6. So your next 0 is 6. That multiplicity is the 3. Since that's an odd number, you're going to cross like that. Okay? So let me just kind of show you what I've done so far and just kind of talk about how you can mostly do this stuff in your head. Okay? Because we're looking at things that are in a factored form. So basically, you just figure out what makes that 0. -5, and its multiplicity is 2. Since it's even, that means you're going to touch the x-axis. You'll see what I mean by that in a minute. The 0 here is 6. Okay? Multiplicity is 3. Since that's odd, that means you cross the x-axis. So you can do all that in your head, just boom, boom, like that. Okay? Are we okay so far? I can't tell. I'll have you do the next problem here in a minute and just see how well you can kind of put this together. So now that you know the zeros are not always the same thing as an x-intercept, but they are now until we learn something about complex numbers. So all you need to do on this is write 3 points. You don't have to show any work on this. The thing is, when you have an x-intercept, y is 0. That's what we mean by an x-intercept, is it's on the x-axis, so the y value is 0. Now, you just take the answers to these zeros, which are 0, -5, and 6, and you fill in those x values like that. So you would have 0, 0, -5, 0, and 6, 0. Those would be your x-intercepts. You want to get to a place where you can take this problem and do all that in your head. You don't have to show any work. Okay, that's your goal. Okay. Now, when you do a y-intercept, you always set x equal to 0. Okay, so that when you do a y-intercept, the x value will be 0 automatically. You got to find y. Okay, so what we do is everywhere we see an x in the original equation, we just plug in 0. And a lot of times, hey, you can do this in your head. So you're really doing f of 0, which is -0 times 0 plus 5 to the second, 0 minus 6 to the third. Okay, and I wouldn't want you to waste a lot of time on this. This is just 0 times 25 times whatever -6 to the third is. So what happens if you multiply 0 by the rest of the stuff? What do you get? You get 0, right? So that means that your y-intercept is 0, 0. So anytime you do a y-intercept, just go to your original problem, replace x with 0, and calculate. And most of the time, you'll be able to do that in your head. You really will, okay? Okay, so that's what we got so far, and we're going to kind of begin to put this graph together then. Is there questions? I'll have you do a problem, and I'll help you a little bit and see if this will help you kind of begin to put this together. So what we learned, and if you weren't here last week or anything, I mean, that's going to be hard to kind of catch up. But what we learned is if you have an even degree, then the graph either goes like this or it goes like this. It depends on whether the coefficient's negative or positive. So since that's leading coefficient's negative, that means the graph turns and goes down like this, okay? So this information, we know our graph is basically going to have this kind of structure to it. Now, it may connect. We'll figure out how it connects there in a minute. But we know that automatically, okay? All right, now we'll fill out that endpoint behavior once I do the graph. I'm going to go ahead and do the graph first on here. Okay, so what you want to do next here is you want to go ahead and draw a graph, just kind of a blank graph, and then I'll show you how to put this one together. Okay, so just kind of draw like a blank graph. Okay, and just label the x-axis. So we've got, you need to go to 6, 1, 2, 3, 4, 5, 6. You need to go to the left to -5. Okay, like that. And then the y-axis doesn't really matter on that, because the y-intercept is 0 anyway. Okay, so here's what you're going to try to do then, is you got a 0 at 0. Put a dot right there at 0. That is an x-intercept, and put C for cross. That will help you to put this all together. Okay, we go to -5. put a dot there. And again, this time we're going to touch, because that multiplicity was even, put a T for touch. Okay, we go to 6, put a C for cross like that. Okay, now, because it's an even degree and the leading coefficient's negative, we know the end of the graph goes like that. Okay, so again, you want to be able to kind of get all this stuff done in your head. Now you have to kind of figure out, how is this graph going to go? You've got to touch, the graph's got to go touch those points. So here's what's going to happen. It's going to go here. It's not going to go through, so that means it has to change directions. And it's got to change directions. This time it goes through, and then it goes through. Now, it doesn't matter how high you make those things called the turning points. The graph's just going to go like that, like that, like that. Okay, that's what I'm looking for. So when you complete the problem, just make sure that you touch -5, you change directions. It's up to you where you change directions. Again, there's not a right or wrong answer there. Then you cross, decide when you're going to change directions, and go through like that. Okay, so that's how that problem would get put together. And what we're saying on this endpoint behavior is, this piece right here is saying if x goes to infinity, which means the graph's going to the right, then the graph's just going down to -infinity. So the answer there we would put is -infinity. Okay, this piece right here would say if the graph is going to the left, then we're going down again. So that would also be -infinity like that. Okay, and what you can always do on these problems is you can close off the problem. Now, when you're doing homework, you don't want to touch your calculator. I can't keep you from doing that. But if you want to learn this the correct way, you do this calculator free. And then if you want to check your answer, you can go back to the original problem and you can put it in as it is. So that would be, we'd have x plus 5 to the second. Okay, then I'd have x minus 6 to the third. Okay, then you can just do a standard window, just do a graph. And your graph is going to be kind of weird the way these things look, but you can kind of see how it's crossing those 2 points right there, and you can see how it's touching there. It's just the graph, you're not going to make it look as good as yours unless you adjust that window. But you can tell you're right. You have the power, okay? Okay, all right. I want you all to go ahead now and go to the next page, see what you can do, okay? And I'll kind of come around and see how you're doing. If you missed last week, it may be a little hard to catch on with just one example, but do your best and I'll give you a little help on this, okay? This recording here, and I didn't look at all the graphs, so I just wanted to kind of see where you got on that. So the degree, I think everybody got that okay. You would do 2 plus 1 plus 3 plus 4. So I think we got a 10 on the degree. The leading coefficient, you're going to take 4. Now that 4 is not to the second, but that's important. Then you would have 1 to the first, really, because that's an exponent of 1. Then you would have 1 to the third. You're taking the number in front of x, and that's what you're computing. So when you work out that arithmetic, you get 4 times 1 times 1 times 1 is 4. Now, when you put those two pieces of information, because that degree is even, and because that leading coefficient is positive, that means your graph is going to look like that. So whatever your graph looks like right now, it's got to look like that. Okay, we'll kind of figure out what goes on in the middle here in a minute. Okay, now the zeros go like this, and you can do all of this in your head. You have -4x squared equals 0 is your first factor. You can do that in your head. That's x equals 0. That has an even multiplicity of 2. So that means you're touching. That's because that's an even number. So you should have that somewhere. Then you've got x minus 3 equals 0. Okay, that'll give x equals 3. So you have a 0 at 3. It has a multiplicity understood to be 1. Since that's an odd number, that means you cross the x-axis. Okay, like that. Okay. Next one you have is x plus 4 equals 0. That would give x equals -4. And then that multiplicity was, what is that? As I wrote over, that's a 3. Okay, so that's a 3. That means you cross. Okay, so we got that. And then finally, you got x minus 5 equals 0. That gives x equals 5. That multiplicity was 4. That means you touch. Okay, so I think everybody's got that. I kind of helped everybody with that, okay. All right. Now, what we do now is just write the intercepts. So you're going to have 4 points, and the thing you have to understand is an x-intercept, y is 0. You don't memorize that. That's how a point looks if it's on the x-axis. It's on the x-axis, y is not anything because you're not moving up or down. Then you just put these numbers in, like 0, 3, -4, and then 5 like that. So it doesn't matter what order you put your intercepts in, those are what those are then. Okay, the y-intercept, you're just going to plug in 0 in for x. So you would work out 4 times 0 squared, 0 minus 3, 0 plus 4 to the third, times 0 minus 5 to the fourth. You can do all that in your head. That would give 0. So that means your y-intercept, you got 0 for y when x was 0, like that. Okay? Are we okay with everything? Okay. Now, here's how you put this together. Okay, this is what you're ultimately trying to do. So I think you're generally doing a pretty good job on that part of it. Now, when we put this all together, well, let's see. We had a 0 at 0, and we said we touch. So I'm going to put T for touch as a note to myself. I had a 0 at 3. I'm going to put C for cross. I had a 0 at 5. And we said we're going to touch there, and we had a 0 at -4, and we conclude that we cross there. Now, we know because the degree is even and the leading coefficient's positive that this graph goes like that. And you use that information to put this together. So here's what you should have come up with. It doesn't have to look exactly like mine. You have to cross there. Then you have to change direction somewhere. It doesn't matter where. You got to touch, so you got to change directions again. Then you're going to cross. Then you got to change directions, and then you got to touch, and then you got to change directions like that. Now, how high these points are, I don't care about that because we don't know. We don't have enough information to do that. But structurally, that's what your graph looks like. Again, you can check that on your graphing calculator. You can determine if you're right on that then. Okay? All right, are we good? Got 5 people in here today. That's just, that isn't cutting it. I'm glad you're here, though. I really am, because when you're here, it's going to make everything a lot easier. And I'm recording all these videos, so you can look after class. You've got to use the resources that I'm giving you. Okay. All right. So now the next thing we're going to do is work with the same idea. This is more of an exercise to kind of help you get a little bit more comfortable with. So what I'm doing on this is you're going to be given a graph of a polynomial, and then what we're going to try to do is find an equation of that polynomial. So I think you'll see one of these on your web work homework. In this box is is what we're going to go through and do. You know, you'll locate the zeros, you'll determine if you touch or cross, you'll find the y-intercept, then you put it all together. Okay, so let's go through a couple of these, and then I'll let you try a couple of these. Okay, so the first thing we're going to do, this is the graph I give you. We're going to write down the zeros. What are the zeros? The zeros are where you cross the x-axis or touch the x-axis. So you have -3 as a 0, and you cross. That means that if you cross, your multiplicity is odd. So what's the lowest odd number there is? 1. Okay, that's what you do. Okay, the next 0 is 2. And since that's an even multiplicity, that means we touch. So what's the lowest multiplicity then? 2. The lowest even number is 2, not 0. Don't use 0. That doesn't make any sense. Okay. Now we go to the next one is 5. That's 5. It crosses the x-axis. So that means you're going to have an odd multiplicity. The lowest value possible is 1. That's all we care about is the lowest possible value. Okay. All right. Where is the y-intercept? Okay, this thing crosses right there. That is your y-intercept, and that is the point 0, -2. Okay, so you're going to have a y-intercept of 0, -2. Okay, that's just all observational kinds of things there. Okay, all right, so here's the next thing we're going to do now. All right, when we put this together, to begin with, we want to write down f of x, and you want to put a letter A there. We gotta find that A. That's what ultimately we're going to do in the problem. And then we're going to put these zeros in. So it goes like this. It's always x minus something. Always. X minus something is the structure of this. So you want to kind of build that together like that. So what I'm going to do is the value of your zeros go right there, but make sure that you have x minus whatever the zero is. Okay, so the first zero is -3. The lowest multiplicity is 1, so put a 1 there to represent that multiplicity. The next zero we got was a 2. That we said had an even multiplicity, so put your 2 there. And then the third zero was 5, and it had a multiplicity of 1 like that. Okay, so write this down now. You can kind of clean this up. You would have f of x equals a. What happens to that minus minus? What does that become? Plus. Good. So that's going to be x plus 3 to the first power. You can always leave the first power off of these things if you want to. I'm just doing that to emphasize it. Okay, so we have that. Okay, so now what we're going to do is our job is to find what the polynomial is. So what we have to do is we have to find what a is. So here's what we do. You take this x-intercept or this y-intercept and you plug in right there. Everywhere you see an x, you're going to plug in a 0 because that comes from the x-intercept. And that -2 is a y value, so that's going to plug in for f of x. Okay, like this. So we're going to solve this equation, and this equation will be easy to solve. It really will. So we'll have 0 for f of x equals a times 0 plus 3 to the first times 0 minus 2 to the second times 0 minus 5 to the first, like that. Your job is to figure out what a is by plugging the y-intercept in. Okay, so let's finish that. We'll have 0 equals a. We got 3 to the first is 3. You can do that in your head. You have -2 to the second. What's -2 to the second? +4. You got to be careful about that. And then you have -5 to the first. So that's -5. Okay, so you got 3 times 4 times -5 like that. Now here, I did something really bad here. I don't know if anybody noticed, but see how I said plug -2 in for f of x? I don't know why I wrote a 0 there. That should be a -2. Okay, that goes there. Sorry about that. I just happened to catch that now. Okay, all right. So now what we're going to have is -2 equals, and then use your calculator if you have to. 3 times 4 is 12. 12 times -5 is -60 times a. Okay, so what we do now is if you want to solve this equation for a, then you got to divide by -60. Okay, what that's going to do is get a by itself. You can reduce that fraction. That's a positive 1/30th. And again, what I'm doing on that is I'm just, if I reduce the fraction, both top and bottom divide by 2. 2 divided by 2 is 1, 60 divided by 2 is 30. Okay, so here's what you're ready to do now. Now you're ready to write your answer. So what you want to do is go to this stage right here that I'm highlighting in green, and your answer is going to be this, but we now know a is 1/30th. So for your final answer, you would just put in f of x is equal to 1/30th times x plus 3. You can leave off that first power, and then x minus 2 to the second, and then x minus 5 like that. Okay, so that would be what that polynomial is. And you'll see one of these or two of these, I think, on web work. And the thing is, you can tell you're right. So if you're getting marked wrong on the problem, which is going to happen to you when you're doing your homework, you can tell if you're doing this right. So get your calculator out and let's do this together so you can make sure we know how to put this in our calculator. So what we're going to do is you want to just press y equals and be sure this 1/30th goes in parentheses. Anytime you got a fraction, that has to be in parentheses. And then just put the rest of it in. You would have x plus 3. You can leave off the first power. Then you would put in x minus 2 to the second. Okay, then you would put in x minus 5, like that. And then you're going to graph this on the calculator and see if it looks like the graph I gave you. And I'm just going to do this in a standard window. So you want to just put that in. You can go zoom 6. Okay, it looks like it, doesn't it? Okay, it's the same graph. It may not look exactly the same, but it's got all of the features. It's got the y-intercept, all the x-intercepts, everything. So you're going to know you're right with your graphing calculator, okay? Okay, any questions about what I did? Okay. All right, let's go to the next page here. I want to do probably one more and then just let you try one. And kind of see if we can get this all put together. Okay, so first of all on this one, let's just kind of look at the details here. Okay, one of your zeros is -2. That is crossing. So what's the lowest multiplicity? It's got to be 1. Remember, if you cross, it's got to be an odd number. Smallest odd number is 1. Okay, the only other zero is here. The only other place that it hits the x-axis is at 3. That touches. So what's its lowest multiplicity? 2, because it's got to be an even number. Okay, and that's it. Those are the only zeros we have. So you don't really need that blank there. So we've only got 2 zeros in this problem. Okay, all right. Your y-intercept is right here. So it crosses the y-intercept there. So that point is 0, -1 there. So identify that y-intercept as 0, -1. Okay, now we've got everything we need to know to start putting this thing together then. Okay, so what we're going to do is going to write this like this. You have f of x, and then put an a, and then you want to kind of get everything put in. Remember, the structure is x minus something. Okay, make sure that you set it up like this. You can kind of skip this step once you get a little practice with this, but the first zero is -2. Okay, that one crosses, so we're going to use 1 as its multiplicity. The next zero is 3, so we put that in. That touched, so we're going to use 2 as the multiplicity like that. Okay, so what we'll have now, just kind of clean this up, we'll have f of x equals a times x plus 2 times x minus 3 the second, like that. You don't care about using 1 as an exponent, okay? So our answer is going to look like this, except our job is to find what a is. So we'll have to do that. But right now we've got, we got this part of the problem figured out, see. Okay, that came from the graph. Okay, so now what you do is you take your y-intercept and you plug it in. The value of y on the y-intercept is -1, so put -1 there. Anytime you have a y-intercept, x is 0, so that plugs in like that. Okay, so what we'll have is -1 equals a times 0 plus 2 times 0 minus 3 squared. Now just kind of finish up the details. This would be -1 equals, and that would be a times 2 times -3 to the second, which you can do some of this in your head if you want to. So that's -1 equals a times 2 times 9. So that would be -1 equals 18a. So what's a? 1/18th, good. Okay, so you got to just solve that equation. So now you would divide by 18, and that would give you what a is then. Okay, so that's kind of the work of the problem. You got a is equal to -1/18th. So that's what goes there, and then that's your answer to your problem right there. Okay. So probably the most challenging part of the problem is probably the last part to me, is just kind of getting the zeros plugged in correctly, and then plugging the y-intercept in. Okay, and again, you could graph this on the calculator, and it would look just like the graph I gave you. So you have that ability to do that then. Okay. Okay. Any questions? Okay. Well, let's do just one problem here. So I'll leave this up there and go ahead and see what you can do on just this one problem at the bottom here. Crap, is that the same problem I gave you a minute ago? Okay, try to do the problem that I just did without looking, okay? Can you at least do that? I think I probably forgot to change that problem. Yeah. So let me just kind of talk about what I did here. So again, when you fill up the zeros, you have a 0 at -3, which tells you, and we're crossing, you can say it crosses the x-axis. And again, I said if you cross, it's got to be an odd multiplicity. Lowest odd number is 1, okay? Then you have a 0 at 2. It only touches. So that means the multiplicity has to be the lowest even number. So you would have 2 there. We also have a 0 at 5. It crosses. That means the multiplicity has to be the lowest odd number possible, like that. Then you add your y-intercept to 0, -2. Okay, that stuff right there, it should be just boom, boom, just right through it. Okay, when you put this together now, it goes like this. Okay, when you put this in, you're going to have the -3 is ultimately going to end up being x plus 3 to the first, because the multiplicity is 1. The 2 is ultimately going to be x minus 2 to the second. The 5 will give you the factor x minus 5 to the first, like that. Okay, and then you put an a there, because your job is to figure out what a is in the problem using the y-intercept. Okay, so what I do now is, since the y-intercept was 0, -2, I'm kind of showing you I plug the -2 in there, I replace all the x's with zeros, and then ultimately, if you do all the algebra and all the arithmetic, you're going to end up getting 130 like I did before, and then that gives you your final answer right there. Okay, so that's how that gets put together, is like that. And then, of course, you could use your graphing calculator if you wanted to graph that. And I'm not going to take the time to do the graphing calculator, but if you put it in, I mean, that's what it looks like, and that matches that graph exactly. Everything's exactly the same. So when you're doing this on homework, you know, be sure that you check in your calculator. If you're not getting the right answer, take a look at what's on your calculator, and that might help you figure out what's going wrong with the problem. Okay? Okay, did we do that okay? All right, okay. Now, I'm going to go ahead and I'm going to go to this page 7 and finish that up before we take a break here. And then when we get back, we'll continue with this. There's some more things I'm still going to do on 5.3 that are very similar. So what we're going to do on this example 8 on the next page is this kind of the same kind of problem. It says find the equation of this polynomial. So it's the same thing that we just got through doing, really. So what we're going to do is we're going to set this up. Okay, so go ahead and just write this on your paper. You're going to have f of x equals a, and then we have 3 zeros. Now, the word root and 0 essentially mean the same thing. So roots and zeros are going to mean the same thing. Okay, so if you did that last problem correctly, the only difference with this is I didn't give you a graph. I just gave you all this stuff anyway. Okay, so what we're going to do on this then is we have a root of 5. Okay, so one of the zeros is going to be 5, so that goes there. Its multiplicity is 3, so that goes there. Okay, all right. Then what we have here, I think that degree is wrong on this too. So let's see, we have a multiplicity of 1. So put the 1 there in the parentheses. Now hold on. That's the multiplicity, I'm sorry. So we have the 0 is -3. So put x minus -3. That multiplicity is 1. And then we had a x equals 0, so put the 0 there. That multiplicity is 1. Now that degree, that was a mistake. That should have been 5. So cross out that degree. That was my mistake. That should be 5. How come 5? How do I know I made a mistake? Look at these multiplicities. What's 3 plus 1 plus 1? That's 5. That's why the degree's got to be 5. Okay, so that was my mistake there. Okay, go ahead and clean this up a little bit. Bring this down. This is f of x equals a. This is x minus 5 to the third. This is going to be x plus 3. You don't need to put the first power there. And then you don't really need to put x minus 0 to the first. You can just put an x there. X minus 0 is x, so we have that. Now what we need to do is we need to find a by using this x-intercept, or this y-intercept. So what we're going to do to find a is we're going to plug the 20 in there, and then everywhere you see an x, you're going to put in the 0. That's the same thing I did on the previous problem like that, okay? So now when we put this together, you want to write down what we have. We have 20 is equal to a times 0 minus 5 to the third times 0 plus 3 times 0. Okay, so what we end up getting on this problem then, and what will happen on this is you're going to end up having 20 here, and all this stuff right here is going to end up just this will end up being negative 5 to the third times 3, and then that'll be a times 0 like that then, okay? So what's going to happen in this case is, if you have that 0 right there, if you have the x equals 0 as one of your zeros there, that's going to cause this stuff right here to all be 0 like that. So you're not going to really worry about a on the problem. So if you put this all together, we would just end up having f of x like this. So we'd kind of have all this put together here. So I just write this as x minus 5 to the third times x plus 3 times x like that. Okay, what would happen is you would end up having 20 is equal to a times 0. You end up getting something that wouldn't make any sense there. And here's why that's wrong. Okay, the teacher was wrong on this also. That y-intercept should have been 0, 0. I totally botched that problem up. Okay, so what would happen is you would end up getting 0 equals a times 0. So a would have to be 0. It's the only thing it could be. Okay, so that one is just basically your answer on this would end up being this then. Okay, with that being your intercept like that. That's what's that? I'm sorry? Why do I plug the 0 in where?
No, why wouldn't you plug in that 0 for a? Or like you
Oh, in for a? Yeah. Well, the thing is, you would find that a would end up having to be 0 on that. So, because what happens on that is, now hold on, that since the y-intercept is 0, 0, then in that case, a would just have to be 1. I just messed that problem up. I should have been more careful on how I typed that. If I would have taken off the 0 at 0, then we could have solved the problem with the 0, 20 just fine. But that's kind of what messed me up there. Okay, so that's the idea. All right, let's go ahead and let's do this problem. You'll see this same kind of problem on the WebWork homework. And what'll happen here is this is something like in my calculus class. We look at this problem quite a bit in a calculus class. So if you're going to take calculus, we just kind of introduce not the calculus idea, but the basic idea. So what this problem is saying is you have a rectangle, and the length is 10 centimeters and the width is 6. So to begin with, I want you to just draw a rectangle. Okay, just kind of draw a rectangle like this, and then we're going to label these sides like this. One of the sides is going to be 10 centimeters. That's going to be the length. And then that width, I'll use this as the width. Just label that as 6 centimeters, okay? So if you had a flat piece of cardboard, you can make it into a box if you do this. So if you went around and you cut out squares out of the sides, took a pair of scissors and cut out the same size square out of every part of that, then you would make this into a box, okay? So what we're going to do is just kind of use a polynomial to represent the volume of this box then. Okay, like that. Now the diagram I tried to take will kind of help you see what happens on this. So after you take out these boxes, imagine in your mind folding this up. You would end up having this little flap here. And if you folded those pieces up, you would make a box. You guys kind of see what I'm talking about by that. So you would make a box when you cut the corners out. There wouldn't be a top to it, okay? So what our job is on this is to represent what we have left here. So I would draw this picture next like this. Just kind of draw a picture of what that rectangle is going to look like. Doesn't have to be perfect, just has to kind of have the idea here, okay? Now here's what you have to reason out in the problem. This whole thing started 10, right? Now the length is not going to be that anymore. It's going to be this piece right here. So you're taking 10, and what are you taking off? 2 x's, right? So what you would have is this piece right here would be 10 minus 2x. Does that make sense? You're just taking off x and another x. So 10 take away 2x would be what you end up with. So that piece right there is now 10 minus 2x, okay? By the same logic, this started 6. What would it be? 6 minus 2x, good. Okay, so we got 6 minus 2x like that. You're taking away 2 x's when you cut out those corners like that, okay? So now the volume, whenever you do a volume of a box, you do the length times the width times the height. So we're ready to write our polynomial then, okay? So the length would be 10 minus 2x. The width would be 6 minus 2x. And the height, what do you think the height would be? Now look at the box. I mean, I fold that up, so how tall would it be? Any idea on that? That'd be x. It's x tall. Because this piece right here is x, and that folds up like that. So x is your height right there. Okay? And then we got that. Now we're going to multiply that out. Okay? You'll see one of these problems like this on web work. And it's a nice problem. Just kind of get students a little comfortable with a few things. So we are going to multiply this out. So we're going to go ahead and FOIL right here. So let's go ahead and do the FOIL on that. I don't think we can probably do that without a calculator. That would be 60. And then the outside term would be minus 2x. The inside term would be minus 12x. And the last term would be plus 4x to the second. And then bring down that times x like that. Okay, so we've done, plenty of foiling. We do that every now and then in here. So this would be 60 minus 14x plus 4x to the second times x, because I'm just putting together the like terms. Okay, now the other thing I got to do is multiply the x, distribute that x through there. So when we distribute x, we're going to have the volume will be 60x minus 14x to the second, and then plus 4x to the third. Okay, what we do in a calculus class for this problem is we try to figure out what the value of x is that makes the box hold the most the biggest volume possible. We don't do that in this class because we don't know calculus. But that's the idea. Okay, does that make sense to you guys? Okay, all right, so that's a polynomial function. Polynomial functions can be used to model all kinds of things, solving all kinds of problems. We certainly use this, like I was saying, in calculus, okay? All right, let's go ahead and take a break, 10 minutes, come back at 1:10. And then we'll kind of push on. We'll get started also on the 5.4 a little bit here today, too. okay? All right, so to begin with, we're going to kind of redo the problems we were just doing for the most part, except these are not in a factored form. So this is going to test your factoring skill. Okay, on this example 1, it's easy to tell what the degree is. The degree is the highest power. So the problems you all were doing was you were adding those multiplicities together. That's automatic. The leading coefficient is also automatic. That's -1. So really, if it's in a multiplied out form, this right here, that tells you the degree right there, and then this right here is the leading coefficient, okay? So here's what you know about this problem already, and you got to get this down to a science here. If it's an even degree, what are the choices? It either goes up or it goes down. Which one is this going to be? It's going to go down because that leading coefficient's negative, so we already know our graph is going to do that. Now, it may loop and connect and touch and all that kind of stuff, but we already know the graph looks like that. We already got that down, okay? So now, down at the x-intercepts, go ahead and do this. Write down the function I gave you. And what we're going to do, anytime you find an x-intercept, you need to set that equal to 0. And we have to solve that equation by factoring. Okay, so this is going to test the factoring skill on here. So what you need to do when you factor something, there's an x in every position, so you always take out the x that has the smallest exponent. Okay, so that means we're going to take an x squared out. If that first term has a negative, then you'd want to take a negative out also. So you want to write this like this. Just put -x squared, then put a blank set of parentheses like that. Okay, you're going to take common factors out a lot. And it's the lowest exponent that comes out. Okay, if it's hard for you to figure out what goes inside, and sometimes it is for some students, then I would recommend in this problem, just divide every term by -x squared. Just do that. Just divide it by that, and that'll help you. All right, so if you do this piece right here, if you're doing -x to the 4th divided by -x squared, that's a positive x squared. Okay, just think of why that is. X to the 4th is x times x times x times x. X to the 2nd is x times x. I mean, you don't have to write that down, but that's what's going on in the problem. You got that cancellation. Okay, then you've got this piece here where you have 6x to the 3rd divided by -x squared. Well, we have a positive divided by a negative, so that's a -6 for sure. And then you got x times x times x over x times x. That's just going to leave you with an x, right? Okay, do that in your head. You don't have to write that all those x's out, and that unless that's helpful to you. Okay, then the last thing we have is -9x squared over -x squared. Well, the x squareds cross out, but a negative divided by a negative is a positive, so we get that. And one of the things you got to do when you factor, and if you're going to go to higher math, well, you better be a good factorer, trust me. So you make sure you're right. Look at this. -x squared times x squared is -x to the 4th. -x squared times -6 is positive 6x to the 3rd. -x squared times 9 is -9x squared. So we know that's right. You have the ability when you factor stuff to tell you're right. But we're not done with the problem yet. Okay, we've got one other thing that we got to do is we have a trinomial that can also be factored. So this part right here, we can factor that as well. So bring down the -x squared. Now we're going to draw 2 parentheses and factor that trinomial. So this goes like this. You would have x and x to get that first term. You would have 3 and 3 to get that last term. And then you got the outer and inner have to add up to -6. So that would need to be a -3x. That outer term would need to be -3x so that they add up to -6x. So that's how that problem factors is like that then, okay? So I'm going to write one more thing on this, because the whole key to this problem is you got to put it in a factored form. And what you do is just like the problems we were working earlier in class today. So I'm going to write this final form as f of x equals -x squared. Now, you can write x minus 3 times itself as x minus 3 to the 2nd. Okay, so that's the piece we're adding is you must factor. If it's not in a factored form, you got to factor it. okay? Now, we're going to do kind of the things that we did a little earlier here. We have two factors. This is a factor, and that's a factor right here. Those exponents are your multiplicities. So if you do negative x squared equals 0, the solution of that equation in your head is 0. It has a multiplicity of 2, which tells you touch. If anytime you have an even multiplicity, that means you touch, okay? The next one is x minus 3 equals 0. You can add 3 to both sides. You don't have to show that step. You want to mostly do this stuff in your head. So you get x equals 3. The multiplicity on that is a 2. So again, we touch, okay, like that, okay? So that's how we do that. After we use the factored form, it's identical to what we did earlier in class. Okay, but it's the factoring is what you got to get skilled at, okay? All right, now when we put our intercepts together, the x-intercepts always have a y value that's equal to 0. So you want to just make sure when you write these as points that y is 0. Well, what are the zeros? The zeros are 0 and 3. So those are your two x-intercepts right there, okay? All right, so far are we okay? Okay, when you do a y-intercept, you set x equals 0. So go all the way to the original. Don't go to the factored form, go to the original. It's easier. So if you just go through and do f of 0, we'll have negative 0 to the 4th plus 6 times 0 to the 3rd minus 9 times 0 squared. In your head, do you know what that is? That's 0. If not, just calculate it, okay? Do all the details. So your y-intercept, what we found is the value of y is 0 when x is 0. And by the way, this is a good thing to do on your homework. If you have an x-intercept of 0, 0, guess what? That's what the y-intercept is automatically. Because what's special about the point 0, 0 is it's both an x and y-intercept at the same time. Okay, so if you get one answer, then it's got to be both intercepts on them. Okay, all right, so now what our job is to go ahead and put this all together and put our graph together. All right, so what we end up getting on this is we'll go ahead and again just kind of sketch ourselves out a graph. Well, that's a bad color for that. Okay, so let's just kind of get our graph together and see if we can begin to put this together now. So let's see. There's my XY axis. So in this problem, we had two zeros. We had a 0 at 3 and 1 at 0. Okay, so when you start putting this together then, I would put a dot right on 3. We said when we have a 0 of 3, we said we were touching. We had a 0 at 0. And we said we were touching there also, okay? And then again, because the degree was 4 and the leading coefficient was -1, that means this graph turns downward like that, okay? And that means now if we put this together, this graph will have to look like this. It'll have to touch that, it'll have to change directions, it'll have to change directions and touch and then change directions like that. So that means your endpoint behavior is, since you're going down, the answer to that endpoint behavior would be -infinity on both of those like that then. Okay, so see, the only thing I'm adding is now you got a factor. Okay, how do we feel? I can't tell. Okay, we'll do some problems in a minute here because I want to see how well you can do your factoring. And I'm going to do 3 examples because there's 3 kind of factoring situations we need to look at here, okay? And not all these factoring things you all are going to know how to do from your background. I think that would be kind of what I think. Okay, so let's kind of start with the easy stuff here. Okay, here's the polynomial I'm giving you. What is the degree? 3. How do you know? Highest power. That's super easy. What's the leading coefficient? 1. Okay, right there. Remember, all you're doing is looking at the highest power and the number in front. That's how you do that. Now, if you're going to do the zeros and multiplicities, you have to factor. I didn't give this in a factored form. So there's a technique. Some of you are very familiar with it. Some of you are not, probably. There's a technique called factor by grouping that you typically learn in like intermediate algebra, algebra 2 in high school, those kind of things like that. So let me take you through how you're going to do this. Okay, when you have 4 terms, see this problem has 4 terms. And if it has 4 terms and there's no common factor, you can't take any common factors out of this at all. There's not an x in every position like the last problem. What you want to do is you want to do this. Put a set of parentheses around the first pair and then also put a pair of parentheses around the next, okay, like this. Now you have to be careful how you do this 16x minus 16, so watch this carefully. You can put the 16x in there, okay, but if you put minus 16 there, you have totally changed the problem. And you need to understand why. Because look at this, what is a minus 16? That's a plus 16, so that's not the same problem. So you need to change that to a plus. Okay, if you don't do that, you've changed the problem. You never want to do that. Okay, so that's going to go like that then. Now we got everything right. So pay attention to that negative right there. All right. Now, what we're going to do is we're now going to take out common factors. Okay, just look at the first parenthesis only. Don't look at the 16 and 16x plus 16. What's the common factor I'm going to take out between x to the third and x squared? X squared. Take out the lowest exponent. Okay, when I take that out, okay, again, if you need to do this on scratch paper, you could take the x cubed plus x squared and divide both pieces by that common factor. If you do that, that's x. You do that, that's 1. So what you get there is an x plus 1. Okay, that's what goes there. Okay. All right. Now we have a 16x plus 16, so we can take a 16 out of that. Okay. Again, we'll have a leftover parenthesis. Again, if you can do that in your head, do it in your head. If you need to take that 16x plus 16 and divide it by 16, you're going to be left with x plus 1 again. And when you do factor by grouping, these things will always end up being the same. X plus 1 will be the same. If they aren't, then you're either messing up or this problem can't be factored that way. So the next thing you do to finish this factoring is, this is a common factor right there. That is a common factor that comes out of the expression. So you end up getting x plus 1. Then you draw a blank parenthesis there. And this is the way I usually do this, which says, hey, all you got to do is just take that and block that out. What's left after that comes out? What do you see left? X squared minus 16, right? So just kind of think in your mind that once you've taken that factor out, then you're left with x squared minus 16 like that. Okay, and we still got one more step to do with that factoring. Okay, so that's factor by grouping. How about this? We've learned how to factor that. What do we call this factoring problem? Difference of 2 squares. Okay, that's the one that goes x 4 plus minus. Okay, we've looked at that before. Okay, so here's what you end up getting here. You end up getting x plus 1, and then when you factor that difference of 2 squares, that's x plus 4 times x minus 4 like that. Okay, I'm going to kind of erase some of that little scratch work there. You don't have to do that scratch work unless it's helpful to you. Okay, so here's what we have now, and your job is you want to be able to tell me what these zeros are just super easy in your head. What is this 0 going to be? -1. What's its multiplicity? 1. What's this 0? -4, multiplicity 1. How about this one? 4, multiplicity 1. See, it ends up being the opposite sign. Okay, that's what you're doing. So what you're going to have then is -1 is going to be a 0. It has a multiplicity of 1, and that tells us that we cross, okay, because it's an odd number. Then we have -4 is a 0. Its multiplicity again is 1, so it's going to cross again. And then finally we have a 0 of 4. Okay, that has a multiplicity of 1, so that's also going to cross like that. Okay, now your x-intercepts are automatic. Once you get your zeros, you write those things automatically like we've been doing. Okay, remember on an x-intercept, y is 0. That's the structure. Then just put in your zeros. You have -1, you have -4, and then you have 4 like that. Okay, so that's what you end up getting there. And then we got to figure out the y-intercept. The y-intercept, you just do f of 0. Okay, so go to your original form, and you'll have 0 to the third plus 0 to the second minus 16 times 0 minus 16. Again, you don't need to get your calculator out. All that stuff goes to 0. So you're left with a y-intercept that is the point 0, -16. Okay, that's what we got there. So now we've got everything we need to complete a graph. Okay, how are we feeling with this zero multiplicity stuff? Okay, it looked like you guys were doing a good job on that earlier in class, and now it's just, can you factor? If you can't factor, you won't be able to do anything with this problem. But if you can, you will thrive, okay? All right, so now what we're going to do on this is we're just going to do the graph and kind of put that together. So down at that space in the bottom, you want to go ahead and just kind of draw yourself a blank coordinate system to begin with, like we've been doing. And then what you want to do is just kind of put all of these zeros on here. So we have 3 zeros. So just kind of do 1, 2, 3, 4. And then you can go -1, -2, -3, -4. And we have a y-intercept of -16. So I would just kind of, when I get all this stuff put together, I would just do this. Okay, we have a 0 at -1, and we said we determined we're crossing because the multiplicity was odd. -4, we're crossing there. 4, we're crossing there. And then we have a y-intercept. Just put it down there somewhere and label it. Okay, but that's going to be an important part of the problem. Just put that y-intercept there. You don't have to do all the little notches. Just label it like that. So if you go back to the very first part of the problem, we had a degree equals 3, and we had a leading coefficient equals 1. So we learned, like last week, that the graph looks like that. If it's an odd degree, it's going to look like that or the opposite of that. So just kind of do your endpoint behavior like that, and then you're ready to put it all together, okay? So just kind of go through here. You're going to have to cross, go through the x-axis, change directions, cross again, go to the y-intercept, and then just go through it, and then change directions, and then cross like that. Again, there's a few different ways to draw that graph. You could, make it change right there and go up through there. It doesn't matter. But the idea is just make sure you're crossing those intercepts and you're going through that y-intercept like that. So that's what your graph looks like. And then your endpoint behavior would be as x goes to infinity, y goes to infinity. And as x goes to -infinity, y goes to -infinity. So that's what your endpoint behavior means. You go to the right, that goes up. You go to the left, that goes down. That's the meaning of that. Okay? And again, what you could do if you're doing your homework, you could graph this thing on your calculator and tell if your graph looks right. That's a simple thing to go through and do. Okay? Okay, so it's the factoring piece on that we're putting together there. Okay, let me do this next one here. One more factoring, and I'm going to give you 2 to do to kind of finish this section up. This is a pretty lengthy section with a lot of information. Okay, so let's start with the easy stuff. What's the degree of this polynomial? 4. What's the leading coefficient? 1. How does the graph go? Based on those 2 pieces of information, what's the graph look like? This way. Okay, touchdown, like this. Okay, that's what that tells you. We already know that information from the problem. Okay, so now we need to factor this. So we go down kind of to this x-intercept piece right here. We're going to factor this. Okay, so this will go like this. So your first term is x to the 4th. So you're going to have x squared and x squared to get that, because x squared times x squared is x to the 4th. Okay, your last term is 4. So you're either going to have 2 times 2 to get 4, or you're going to have 1 times 4. Which one do you think it would be? As that 5 tells you. 1 and 4, right. 2 and 2 cannot be made to add up to 5, but 1 and 4 can. So you're going to have 1 and 4 there. Okay, now think about how you're going to make the inner term and the outer term add up to negative 5x squared. Well, you're going to have a negative 1x squared and a negative 4x squared to make that happen. Okay, so that's how your factoring begins, is x squared minus 1, x squared minus 4. Okay? Can you do anything more with x squared minus 1? X plus 1, x minus 1, that's the difference of 2 squares. How about x squared minus 4? X plus 2, x minus 2, okay? So you got to get solid with that factoring. So what you're going to get is you're going to get f of x equals x plus 1 times x minus 1 times x plus 2 times x minus 2. So there's the factoring aspect. Now from here, it's all kind of the same stuff, which I kind of sense that we're doing pretty well with that now. So we do have 4 zeros, so I think I probably needed another blank here. So what we have here is that 0 is negative 1. So we'll have a 0 of negative 1, multiplicity of 1, which will tell you cross. We have a 0 of 1, has a multiplicity of 1 again. That'll tell you cross again. You have a 0 of negative 2, multiplicity of 1, cross again. And then we got one other one we had that you need to just add in here. We have a 0 of 2 with a multiplicity of 1. And again, that'll tell you that you cross. Okay, right there. Okay, so we got everything we need now to put together our graph right there. After you get that factoring put together, then you got the ability to put your graph together. Okay, so when we go down to creating our graph now, you want to go down, just kind of draw yourself a graph, and then we'll begin to put this all together like this. So our zeros we had on this were negative 1, 1, negative 2, and 2. So we'll just kind of put in the 2 and the negative 2. We need to get the y-intercept also. I forgot about the y-intercept. Okay, so on the y-intercept, you can learn to do the y-intercept in your head. You really can. So if you go to the original problem, plug in 0 for x, so you would have 0 to the 4th minus 5 times 0 to the 2nd plus 4. Okay, that'll give you 4. So your y-intercept would be 0, 4. Okay, y-intercept on these problems will be easy. Just plug x equals 0, and then just put your y-intercept there. Okay, so now when we begin to piece this together, what we found on the problem is we found that at negative 2 we were crossing. We found at negative 1 you were crossing. We had a y-intercept. I would just label that as 0, 4. We found at 1 you were crossing, and at 2 you were crossing as well. Okay? And we also found at the beginning of the problem we had an even degree with a leading coefficient. Like we learned last week, that tells you the graph is going up in the endpoints like that. Okay, now you just need to figure out how to loop that through all these things, all these points. So that's going to cross, it's got to change directions, it's got to go through the y-intercept, and you can make it cross that y-intercept, or you can make it go straight down if you want to. It doesn't matter. You're not going to know that. Make that cross, make that cross. So it's kind of like a big W. Okay, that graph is not going to look exactly like that, but it's going to have that structure. Okay, so your endpoint behavior is going to be infinity on both of those things then. Okay, so that's how that gets pieced together. Okay. Okay, so there's 2 more things. So I want you to do the next 2 problems, and then that'll wrap up what we're doing on this section. There's a lot of stuff in the section, but that'll give you everything you need to know. Okay, so see what you can do. I'll kind of come around and give you some help if you need. Okay, and I'll just kind of talk through some of the key details of this problem number 1 you did. One of the first things you want to do is make sure that you did your factoring correctly. So I think I helped everybody with that. You have x times x minus 2, x minus 4. So this is something I could tell a lot of you didn't catch on to. What you're always doing is just setting each factor to 0. You got x equals 0, you got x minus 2 equals 0, you get x minus 4 equals 0. Okay, that's why one of your zeros is 0, one of them is 2, and one of them is 4. So you want to make sure you have all this information here. Y-intercept was 0, and then your graph has to look like that, okay, roughly. It doesn't matter how far down these minimums and maximums go, just has to roughly look like that, okay? So let me just leave that up there for a minute and see if we got a question or if we need, anybody needs to correct anything on that problem. Okay, are we doing pretty well with that problem? Okay. That to help with factoring. And factoring, you got to work on it. Okay, here's what you should have got on the last one. If you didn't have time to finish that up, you want to go ahead and get this information on here so you have it for your record. So basically, here's your factoring right here. And you got to do this factoring in 2 steps. The first step of that factoring is x squared minus 4, x squared minus 25. Then you have those differences of 2 squares. Okay, so you would end up having that information when you do your factoring. See, again, you don't have to write this down, but you're doing x plus 2 equals 0, x minus 2 equals 0, x plus 5 equals 0, x minus 5 equals 0. That's why you can do the zeros in your head, okay, because you don't have to show any work when you solve those equations. So you'd have a 0 at negative 2, 2, negative 5, and 5. Multiplicities are all 1, so you cross everywhere on that. And then the other thing is, because the highest power was even and the leading coefficient was even, that's how we know the graph turns up like that. Everything crosses, you have a y-intercept of 100, so your graph would cross through the zeros, it would cross through the intercepts like that, okay? Now you could, make it kind of go through that y-intercept and down. Okay, that doesn't matter, but that's roughly what that graph would end up looking like, okay? All right, so that'll wrap us up today then. So if you need to get that copied down, I'll leave this up here, and then I'll see you on Thursday.